Alright, so here I'm going to explain kind of the basics of how an engine works. It's just one of the things that I'm learning. I actually took auto mechanics in high school and learned a lot there. But I thought I'd share kind of what I know and what I've learned so far. So this is a drawing of the engine. Doesn't look exactly like that, but it's pretty close. It gets the idea right, the mechanics right. Um, so what happens is this is the crankshaft, and when this rotates, um, rotates like this. It's kind of hard to see when it's in 2D, but when that rotates, a set of gears in the transmission uh, go straight to the wheels and causes the wheels to rotate. So the question is how do you get this thing to rotate on its own when you press the gas? So that's what I'm going to explain. So these are pistons, and I know this is kind of crudely drawn, but these are pistons, and there's 4 stages that a piston goes through, and so I'll explain it. So the first stage is the intake stage, and these pistons here are in a chamber. There's a second drawing here that gives you a little look with the shading. It kind of gives you an idea. So this is a solid cylinder where with a piston inside, and it's airtight. There's no gap, or very 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 little gap between the cylinder walls and the piston, and so it doesn't let any air escape. Sorry for the bad camera. So what happens is the piston goes down, and this valve opens up, and it lets in air that's combined with gas, almost like a mist. And it's highly flammable, obviously. It's basically flammable gas. And it goes into the cylinder. Then the next phase is the compression stage. And this stage, both the valves are closed. And since it's airtight, once the piston goes back up with the fuel air in the chamber, it compresses all the gas into a very small amount, creating a huge amount of pressure. And then it's really smallly drawn, but this little thing is the spark plug. And what this thing does is at the compression stage, it ignites a little spark, hence the name spark plug, and that ignites all this gas that's built up on the compression stage, and that creates a lot of force. It's basically an explosion happening, and that explosion causes the piston to pull back down, and that's what creates that energy to rotate the crankshaft. And then the momentum will bring the piston back up, and in that phase, the second valve will open, and all that burnt air from the gas that ignited is pushed up through the second chamber and out the exhaust pipe. That's what your exhaust is, and that leads all the way through the car, through the exhaust pipe, out the exhaust, and gets rid of the burnt air gas that was left over. And then it repeats that cycle, and then it goes back down. The intake brings in more gas, compression, combustion, exhaustion, or exhaust. And it just keeps repeating that cycle, and that's what causes the crankshaft to rotate, which through a set of gears is connected to the wheels, causing the wheels to rotate when you hit the gas. Now, what causes the valves to open up on the right timing is, now I'm not 100% sure on how they do this. It has something to do with the flywheel. There's a marking on one of the gears over here, as you can see. So as the crankshaft rotates, there's a gear here that has a belt that's attached to another gear, which is attached to this thing called the camshaft. And that's the thing that's controlling the valves opening and closing. So as you can see, there's these little notches on the camshaft, and when the camshaft presses down, it opens up the valves. Obviously, there's nothing when it's on the compression stage. There's nothing. None of the camshafts can be pressing down on the valves, so they'll both be closed. Same with the combustion, because you could have a lot of problems if it combusts and one of the valves are open, because then all that ignition will go out the valve and it'll backfire and stuff. And so it's all about the timing. And like I said, I'm not 100% sure. The timing part's really complicated and complex, but it has everything to do with this camshaft gear wheel here. And since these two are connected, you're able to time it. The mechanics, whoever builds it in the factory, can time it to where the camshafts are in the correct. Actually, the whole thing is a camshaft. I don't know what these little nodules are called. I can't remember. But they make it to where they're in the right place based on the actual wheel itself relative to the camshaft wheel. And so as this rotates, the belt causes this to rotate as well. So they're in perfect sync with each other, and hopefully that makes sense. Here's a better diagram. I added some shading. So also the camshaft here with the valves, there's also valve springs, so that when it pushes down on it like this, I didn't really emphasize it in the drawing, but the springs will compress, and then once the valve goes off, the camshaft goes off the valve, the springs contract again or expand again, going back to the original position, like so. And there's more to the wheel, we established the flywheel that rotates the camshaft, and then on the other side it goes to a whole set of gears that go to your wheels that rotate the wheels, which causes the car to go. And then we've also established the camshaft wheel. I can't remember if that's what it's called, but you get the idea. But it's also connected to many other things, such as the fan, and I'll explain what that's for. So you'll see these little holes here, in here. As you can imagine, with all these explosions happening essentially during the combustion stage, the engine gets very, very hot, and so hot that it'll eventually melt the metal. And so what happened is coolant was invented, and we have this coolant, which is a liquid, flow through these little chambers here, and the water or the heat dissipates into the coolant, and it keeps the engine cool and from overheating. And then it's pumped. The coolant is kind of like a heart. It keeps pumping more and more of this coolant throughout the system. It doesn't just stay in one place, because otherwise the coolant will eventually get boiling hot too and wouldn't really be doing anything. So the coolant is being pushed by the water pump along, which is also attached to the engine's belt, just like it is with the camshaft or the flywheel and the camshaft wheel. There's also a water pump, and that's my vague drawing of a water pump. Like I said, I wanted to get the idea across. I wasn't trying to go for visual accuracy. I didn't have the time for it. But as the engine is going and the belt is spinning all these wheels, the water wheel spins, and there's kind of a fan inside, and there's coolant inside of that, and it's basically a pump, and that's what's pumping what's moving all this coolant throughout the engine through series of hoses and these little gaps in the engine. And then eventually the coolant goes back around through a tube here, into a radiator right here. That is the radiator. And the radiator's job is to cool off the coolant. Because, like I said, it's going through the engine, and so it's very hot. And then it returns to the radiator. And the fan, radiator fan, I think is what it's called. I don't know. It's a fan. Is also attached to the belt. That's, all these gears are connected to the same thing. So as the engine goes faster, so does all the coolant pumps everything faster relative to how fast the gears are moving. So it stays in like perfect sync. And so this fan is attached to this belt too, and it rotates the fan, and the fan blows cool air through the radiator, cooling off the coolant, and then it cools off, and then it goes back into the engine. There's also a alternator, which I think that was supposed to be the alternator. It's basically a square, looks nothing like that. But an alternator, what that does is it charges the battery. So there's a coil inside that alternator, and as it spins, it uses, I think, magnetism, I believe. I might even make a different section on how that works because it's been a while. But essentially, as this belt spins, it turns the gears, and it recharges your battery, so that your battery has a much longer life. So as you're running the vehicle, the alternator is actually doing most of the work on your battery, like so. And there's quite a few other things that's on your little belt gear system. Here's a little diagram, or drawing, I should say, of the brake system. And like I said, this is all crude. I'm still relearning all this stuff. But if you take off the wheel and the hubcaps, and you take off the rims, you'll see this. And there's bolts here, and that's where the rims go lock onto. And once you take all that off, you'll see. Well, you won't see exactly this. So it'll be a lot more detailed, but the rotor, which is what is spinning, and then this is stationary. This is the caliper. And how brakes work, when you hit the brake, let's go over here. So this is the rotor here. You're looking at it from 90-degree angle. So this is the rotor, and this is the brake pads. And the brake pads right here. So this is the caliper, and this is the brake pad right here. And the brake pads, there are two of them, one on each side. There's another one on the other side of this. And they basically sandwich the rotor like this. Love that sound effect. And that creates friction, which stops the vehicle. And how that works is you have these two brake pads here. Here's the rotor that's spinning as you're driving. And when you press the brake, the brake fluid goes through the caliper and then to the other side of the caliper as well. And these right here are pistons. And it causes the pistons, due to pressure that you're building with the brake fluid. When pressing the brakes, which is essentially what you're doing, you're pumping fluid into the caliper. It causes the pistons to go forward, pressing up against the brake pads, which eventually move the brake pads and compress against the rotor, creating friction and eventually stopping the vehicle. Belt. seemed like an electrical problem. Where's the battery at? Here's the battery. At work, we're just doing diagnostics on the truck, checking oil, things like that. There's the cooling fan that cools off the radiator. You can see it's attached to the belt from the engine. And there's the radiator. I'm at work right now. I'm gonna be working on the car right after work. Didn't get much sleep last night. But yeah, I'm gonna work more on the car. God only knows how long I'm gonna be there. And right after work, it's about noon right now, so we still got some time to get more stuff done here and get out.
And then this started spraying. Oh, I don't know if it started spraying, but somewhere in here started spraying. I don't know if it covered the inside.
So this truck had power steering fluid leak. We're trying to find out where it's coming from, so we had to remove a bunch of parts just so we could see the lines where it was leaking from. It was leaking everywhere. We also changed the oil and all that in the oil filter.
This interference, which I've never known power steering to do. It's weird.
That is weird.
But that started. And I'll watch and see if we can find anything. Because that's going to be the easiest way to tell where it's leaking from.
Yeah,
Because
true.
that way we
Want me to get underneath it and see if anything drops from under there?
honestly, it is way over for me. It's topped up now, but like.
Right there by that. See it dripping. Dripping right by that one on the left there.
Do the nice scientific test here. It's water.
So we turned on the truck. You see the belts moving. We're seeing where the leaks are coming from on the brake or the power steering fluid. Once we turn it on, we're hoping we find where the leak is. And turns out it's freaking everywhere, and it's coming from the actual pump itself. There we go. Yeah.
Where the actual issue is originating from. We know it is either one.
Yeah.
Most likely, I'm guessing probably pretty much every connection.
There's the line.
System's probably
Wait,
ballistic.
is this right here? Is that the power steering that I'm holding on to?
Is leaking.
Oh, where it meets the reservoir?
Yep. Which, like I said, that was already a known thing.
Yeah, and you don't think that's where, like...
That's not the majority of it. It's not a big enough leak.
Because it's not leaking.
It is not.
It's enough that when I wiggle it, you can
half
tell
a bottle.
liquid
Yeah,
there.
yeah.
But, well, you know what that means?
It means we're probably gonna need a breaker bar because
You know what that means?
fucking thing ain't moving.
I think I see a leak, or a leak. We gotta get that shit in. Don't worry, you won't be in it.
I don't think we're gonna get this shit in there.
Ah, god damn it.
Right in your face.
Spent about 7 hours working on this vehicle. It was really hot. It was about 100 degrees with the humidity. We were sweating like crazy, got all greasy and hot. It was disgusting, but it was a lot of fun. So, what's the solution, you think?
Well, it could be the
When
way
I checked the oil, the oil was not full. Like when I checked on the dipsticks.
which is
But
normal. Usually, it would be in the bottom of the oil.
so
Okay, that's where the oh yeah, that's it right there. Yeah.
Definitely something. It looks like metal.
Ew.
Then
That's bad. We've been working on this for about 2 weeks now, for about 3 or 4 hours after work. Completely stripped the engine on a old Camaro. Just getting new parts, things like that. And, did a lot of work on it. Really hot days too.
Get it kind of somewhere I can. But I mean, if you look at most of the, if you look at like most of the engine.
It's cool.
It's a little rough in there, but I need to remember. Walk with me? Nope, doesn't want to walk with me today. Sometimes it walks with me and I can actually spin it.
Oh really? Pretty strong, dude.
It's not too bad if you have the right setup.